Okay, in this video I go over the project management homework solution. I'm going to just do problem 15, which is the Excel based on how to calculate the probability of meeting a due date. So we were given in problem 10, I think it's problem 10, we were given activities and predecessors. And in this problem, we're also giving some estimates of the times to complete the task. And we're giving 3 estimates for each activity. And from these 3 estimates, we can calculate an average and a variance. The formula for average, say weighted average, it's 1 part optimistic plus 4 parts most likely plus 1 part pessimistic divided by 6. Copy that down. The formula for variance is the pessimistic minus the optimistic squared divided by 36. You can copy that down. Within Excel, you need to calculate the earliest start, earliest finish, latest start, and latest finish for each of these. The formulas for the earliest finish is just the earliest start plus the average time. You can copy this down. And then the formula for the latest start is equal to the latest finish minus the average time, and you can copy that down. The hard part is calculating the earliest start and the latest finish, and it's a function of the predecessors. So if you've drawn the network, you can use that, or you can look at the predecessor column. So for the earliest start, activity A, the earliest start is the start node. For activity B, it's A. For activity C, it's A. For activity D, it's the maximum of B and C. For E, it's B. For F, it's the max. C, D, and E. And for G, it's E. We do have a finish node. So it's the max of F and G. And how do I know it's F and G? Is because if it's not listed here, then it's going to be linked to the finish node. So F and G. All of these should be the same. So when we work our way back, how do we calculate for the latest finish? G, it's the finish node, is its successor. For activity F, it's also the finish node. For activity E, it's the smaller of F and G. For activity D, it is F. And again, this is based on the network, or I'm just looking at the formulas and across. For C, it's the smaller of D and F. For B, it's a smaller of D and E. For A, it's a smaller of B and C. Once you have those in place, you now have the critical path where if the earliest start and finishes are equal, or the same thing, the latest are equal. If they're equal, that means you have 0 slack. So how you calculate a slack is to take the latest minus the earliest. And you can either use the starts or the finishes. So when you have 0 slack, it's on the critical path. So right now the critical path runs through the start node A, B, E, G. That's the critical path, is the ones who run through that. Now the question is, what's the likelihood that you can meet a deadline of 27? So first of all, we can calculate the average completion time, which is 21. This is it. It's one of these, but you can calculate this by use a sum if. We're going to sum, and we're going to look here, and we're going to look for zeros, and then what we're going to sum are the times, the average times. There's your 21. And all it did was sum the numbers on the critical path. So if I highlight them, if I highlight those, the sum is 21. We also need the variance. Use this same principle, sum if, and it's only looking at activities that have a slack of 0 because that means it's on the critical path. Once I have the variance, I can calculate a standard deviation. And now that I've got an average and a standard deviation, I assume that when I sum my activities on the critical path, the overall project length is going to be normal, centered at the sum of the average, or centered at this with the standard deviation of this. So the probability of meeting a 27-week deadline, you can use the norm.dist formula to figure that out. Your first argument is the x value or the deadline. Then the mean, the standard deviation, and the last argument is 1. So the likelihood of meeting a deadline of 27 with an average of 21 and a standard deviation of 2 is really, really high. What if I would make that 21, which is the average? Well, the likelihood of meeting that is 50%. So you wouldn't quote the average. If the average completion time is 21, let's say these are in weeks, you wouldn't say, well, I'll be done in 21 weeks. That's not, you're only going to be right half the time. That would not be a good answer. If I would quote 24, then the likelihood bumps up, so that's good. So depending on how likely you need to be, you can bump that up. And so if I want to quote a deadline of 27 weeks, it's almost guaranteed. It's 2 out of 1,000 times, or less than 2 out of 1,000 times, would you not be able to meet that deadline. Thanks.